Hi everyone, this is Dr.R.Alarmelu Mangai, Assistant Professor, Department of Computer Science, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. So in this video, we are going to discuss about finite automata. So what is this finite automata? Finite automata are used to recognize patterns. So finite, it is bounded. Automata, it is automatic. Now it takes the string of symbols as input and changes its state accordingly. So by taking a symbol in a string, it will go to the next state. So when the desired symbol is found, then the transition occurs. So what do you mean by transition? It moves from one state to another by getting an input symbol. And at the time of transaction, the automata can either move to the next state or stay in the same state. So by getting an input, what will happen? This finite this will move to the other state or it will stay in the same state. And finite automata has two states. What is that? Accept state and reject state. What do you mean by accept state? If the strings are got accepted and if it reaches a final state, then you will call it as an accept state. And if it is not reaching or the final state, the set of symbols which is not accepted, then you will call that as a reject state. So in this figure, you have seen that two inputs are coming out from A. So by taking 0 as an input, it moves to the next state from A to B, which is a final state. But by taking 1, what happens? It goes to the next state C, which is called as a dead state, that is hanging state, which is not accepted. So the strings that are not accepted will go to the dead state, that is it will not reach the final state. Then we are going to see about the formal definition of finite automata. So it is nothing but a collection of 5 tuples Q, sigma, del, Q naught and F. So what are those 5 tuples? That is Q is nothing but finite set of states. So different states are denoted inside your Q. And what is the sigma? As we have studied already, it is nothing but what? Alphabet. So what that alphabet will have? It will have a finite set of input symbols. And next one is Q naught. Q naught is what? It is an initial state. What do you mean by initial state? From where the process starts. And next one is final state, where it reaches the end. And next one is transition function. What do you mean by transition? Moving from one state to another. So this transition function denotes by getting an input, what happens for the state. Is that staying in the same state or it is moving to the next state. Then next one is types of automata. So under this finite state automata, you have got two types. One is deterministic finite state automata and the next one is non-deterministic finite state automata. So what is this deterministic finite state automata? It is nothing but it refers to the uniqueness of the computation. So in this, the machine goes to one state only for a particular input character. So what do you mean by this? It will accept only one input and then it will go for transition. Okay, so here DFA does not accept the null move. So without any input, that is epsilon, it will not move to the next state. So deterministic finite state automata is nothing but by getting an input, it will move to the next state and it will not accept any null characters. Okay. Then next one is non-deterministic finite state automata. So this is nothing but it can accept more than one input at a time, and also it can accept a null move, that is it can accept or use an epsilon to move to the next state. So what is the difference between the deterministic finite state automata and non-deterministic finite state automata? So the deterministic finite state automata, what happens? It will accept only one input at a time for transition and it will not accept the epsilon, which is a null string or null character. But here in the non-deterministic finite state automata, what happens? It accepts more than one input at a time and also it accepts what? A null move, that is epsilon. Okay. So coming to the assessment part, you have to explain the finite automata. What is this? Finite automata, with the example of the diagrams we have seen before. So here in this differences, you can see here 0 and 1 are taken as input from moving from B to C. So at a time it can accept 0 or 1 or 0 and 1. Okay, but coming to this finite state automata, you can see it can use only one input at a time. So this should be explained with the diagram. And we have referred Java point, and in the next session we are going to see about the state transition diagram and the state transition table. Okay, thank you.